.2640-ish. You know, okay. All right, now that was a necessary step so that I can ask you the next question. This is all example one, right? Next question. Approximately how many bacteria, many starts with an M, were in the culture after 4 days? Okay, so we're starting with 25. And we know almost 10 days later there was 350. So I'm asking you, after 4 days, not 4 days after the 10 days, but after the 4 days from when we started, how many bacteria do you think we have? Okay? So if we're just trying to ballpark numbers, we start with 25, and it's growing, so more than 25, right? But not quite 350. We don't get up to 350 until t equals 10-ish. So we should get something in between 25 and 350, but that's still a pretty big neighborhood, right? So how do we go from here? It's following this model, right? If it's growing exponentially continuously, it's following this model. Do I know why? Do I know the population after 4 days? That's what I'm looking for, right?
Yeah.
This y, I was meaning to point to that. But we do know that y sub 0 is still 25. We just found previously that k equaled this 0.264-ish. And do we have a t that we can plug in now? 4, right? So we'll multiply the k times the 4, and this is all arithmetic that the calculator does, right? Okay, now let me ask you this. Would I be able to answer this question without knowing k? K would be a critical piece of information, right? So what if we hadn't found k here in part A? You still can get it. I could go straight from here to asking you this question, but you have to take the necessary intermediate step of finding k on your own, okay? So you're given the information to be able to find k, so you'd have to do that first usually, and then, like I said, that's a calculator problem from there on out. Okay, what are y'all getting? 71.87121414 is what my calculator is saying. Now, if you're using a more approximate k from Tuesday, you're probably getting a slightly different answer. But here's the thing: what are we talking about? When I say y equals this number, what is y representing in this problem? How many bacteria you got? Do you think you can have 71.87 bacteria?
Yeah.
How? What does 87% of a bacteria look like? What's 0.87 bacteria? Probably, if we're counting things, we're probably going to have to count in whole numbers, right? So I would say something like y is approximately 72 bacteria. Okay? I don't think it makes sense to say we have 71.87 bacteria.
Haven't split yet.
What?
Haven't completed yet.
Yes, yeah, there's some cell division happening and it's almost complete. Yeah, no.